Hello, so this is the last video covering the homework from May 5th, 2020 here, common ion effect, pH, and solubility. So we're looking at number 41, part B, so I already covered 41A in a previous video. So here we have iron hydroxide, and it has a very, very, very small KSP value, so it's largely insoluble, but remember, things always dissolve to some degree. And a pH of 5. So we're going to use that in our problem here. So of course we have our Rice table, reaction, initial change, and equilibrium. This is pretty much the same as always. We do not have any iron cation in the solution, and it increases by an X or an S, that molar solubility, such as S, that equilibrium. And then we have 3 hydroxides. So that's the question here is it increases by 3S, just like we've been doing. S or X, either's fine. But we have this value here at equilibrium that's increased by 3S, and that's going to be based off this initial. So how do we find that? So we actually can use this pH value to figure it out. So the magical pH box of power has conversions. That's on Google Classroom, recommend it. But you can use it and know that 14 equals to pH plus POH. So POH is just the counterpart to pH. And you can actually use that to solve for, in this case, we want to find POH. So I'm going to go ahead and do that. So as you can see here, the POH is 9. And we're going to use that, again, using the magical pH box of power to transfer it to concentration of hydroxide, because that's what we really need. So we went from pH to POH, and now we're going to go to concentration of hydroxide. So again, going from POH to concentration of OH, the formula is 10 to the negative POH. So all you do is plug in the POH, which is 9 here, and then you get the concentration of OH. And notice how this is a much larger number than the KSP value, so that means this is very important that we consider in this buffered system. And of course, I'm going to plug this into the Rice table. Okay, now that I have it in my table, I'm good to go here to set up my KSP in the equilibrium expression and plug in these values. And we are, again, looking for, I believe, the molar solubility of iron hydroxide in this given environment. So I'm going to go ahead and do that with the KSP. Okay, so after filling in the Rice table with our information from finding the concentration of OH, again, based off of the fact we have a buffered system here with a known pH, you can plug everything into your table and then set up your KSP expression here with, of course, the correct exponents, 1 from this molar coefficient and then the 3 from this molar coefficient. And then you can just plug in your equilibrium values there. So these go in, and then again, our KSP value for iron hydroxide is super, super small. So that 10 to the negative 38 is very, very small. So we can be, this falls under a negligible X type of equilibrium problem, so we can drop this 3S here. It's so small it doesn't matter enough in the calculation that we can get rid of it. And so we just have this amount cubed. So all we have to do is solve for S, which is the molar solubility, in which case you get 4 times 10 to the negative 11 moles per liter of iron hydroxide dissolved in a solution that is pH buffered at a pH of 5. And that's how you do this one. Then 41C is similar, you just have a higher pH, so we follow the same strategy. Thanks, guys.